Good day, students. Welcome to math.serve.com. In this clip, we're going to be dealing with arithmetic sequences given for terms. Alright, the instructions for the examples that we're going to be working on are as follows. We're to determine, first of all, if the given sequence is arithmetic or not. Part B, describe the growth pattern. And then C, we're to find the next three terms. Part D, we have to find the explicit formula for the nth term, and then we'll use the explicit formula we derived to verify if the result we got in part C is in fact correct. Okay. Part E, we'll find the recursive formula for the nth term, and then lastly we'll find the value of the 52nd term. Alright, for number one, what if we have the arithmetic sequence 2, 4, 12, 48, and the sequence goes on. So let's look at part A. We're to determine if the sequence is arithmetic or not. Okay. Alright, so to do this, let's go ahead and rewrite the sequence 2, 4, 12, 48. Now this is the first term. We can use the notation a sub 1 to represent the first term. The index of a tells you the position of the term. Okay, so a sub 2 refers to the second term, a sub 3 refers to the third term, a sub 4 refers to the fourth term, and the pattern goes on. Okay, so one thing you want to note concerning arithmetic sequences is you have repeated addition or subtraction of exactly the same numerical value known as a common difference. So if you add or subtract the same number every single time, then you have an arithmetic sequence. If not, then you do not have an arithmetic sequence. Okay, so let's see if we have a common difference here to determine if it's arithmetic or not. So let's start by looking for the difference between the second term and the first term. a2 minus a1 is 4 minus 2, which yields 2. So that tells us that to go from 2 to 4, we just simply add 2. That's the common difference between the first and the second term. How about the third and the second? a3 minus a2 is 12 minus 4, which is 8. So this tells us that to advance from the second term to the third term, you add 8. Now what does this tell us automatically? It tells us that this is not an arithmetic sequence because you do not have a common difference between the first three terms. Alright, so let's go ahead and write down a statement. The given sequence is not an arithmetic sequence. Why? It's not an arithmetic sequence because we do not have a common difference between the first three terms. Okay? The first three terms. So in order for it to be an arithmetic sequence, you must have exactly the same difference between all the terms that are provided. So with that, you have sufficient basis to conclude that the pattern will continue forever. Okay, so this failed the test in just the first three. Had it passed the test in the first three, we also have to test the fourth one just to check to see if the pattern continues. Alright, so in this case it fails early, so we just stop the whole process and write our conclusion that this sequence 2, 4, 12, 48 is not an arithmetic sequence. Alright, let's try another example. Question number 2. What if we have the sequence 11, 4, -3, -10, and the pattern continues? Alright, we're going to be answering the same questions that we presented in number 1. So let's start with the A part. Is this sequence arithmetic or not? Okay, so we have 11, 4, -3, -10, and the pattern continues. Okay, so this is A1, first term, second term A2, third term A3, fourth term A4. So let's see if we're adding or subtracting the same number every single time. That will indicate that the sequence is arithmetic. Okay, so from A2 to A1, what's the growth pattern? A2 minus A1 is 4 minus 11, which is -7. So that tells us that to advance from A1 to A2, you subtract 7. Okay. From A3, how do you go from A3 to from A2 to A3? Let's find the difference. A3, -3 minus A2, 4. What's the difference? -7. Oh, the same as the previous one. So to advance from A2 to A3, you subtract 7. From, how about A4 to A3? From A4 to A3, we have -10 minus -3. So if you work this out, minus times minus is plus. You slash and dash. This becomes +3. -10 plus 3 is -7 again. So what do you notice? We are subtracting -7 over and over again. So since we have a common difference here, the conclusion is that the sequence is arithmetic. Okay, so let's go ahead and write down our conclusion. The given sequence is arithmetic because it has a common difference. We're subtracting the same number every single time. It has a common difference of D equals -7 every time. So that is why this is an arithmetic sequence. Alright, let's advance to the B part. For the B part, we are to describe the growth pattern. Okay, so let's go ahead and write that down. So for part B, we need to describe the growth pattern. So the growth pattern is straightforward. You subtract 7 every time. Okay, so you subtract 7 every time. That's why we have a common difference of -7. Part C, we're to find the next 3 terms using the same pattern. So we have 11, 4, -3, -10. Okay, so that's what's given. We need to find the next 3. Okay, so as indicated earlier, this is A1, 2, 3, 4. So if we want to find the following terms, we just follow the same pattern. Okay, so A5 is going to be A4 minus the common difference. So it's going to be -10 minus 7, because that's what you do every time. That will give you negative 17. And then A6 is going to be A5 negative 17. Subtract 7 again, which will give you negative 24. And then A7 is going to be A6 negative 24. You subtract 7 and you get negative 31. Okay, so let me put the answers here. So this one is negative 17, and this is negative 24. So what we're doing is we're repeatedly subtracting 7. So from here to get this one, we just subtract 7, and then we subtract 7, and then we subtract 7 again. Just using the common difference to generate the next 3 terms. Okay, so there goes the next 3 terms. Now let's advance to part D. For part D, we are to find the explicit formula for the nth term of the sequence and then use it to verify the results we got in part C. Basically, these 3 terms, A, 5, 6, 7, are they correct? We're going to use our result in part D to verify that answer. Alright, so let's put part D right here. So for part D, we're to find the explicit formula. Okay? Alright, so to generate the explicit formula for this particular arithmetic sequence, we're going to use the nth term formula for all arithmetic sequences. Okay, so formula for nth term. The formula for the nth term of an arithmetic sequence is given by an equals a1 plus n minus 1 times the common difference d. Okay, now to generate our explicit formula here, we're going to use the following values. A1 is the first term of the sequence, which is 11. The common difference d is negative 7. We determined this earlier. N is just going to be n because we're looking for the nth term. And then an is also going to be an because n is n. Now let's use this information to determine what the explicit formula is. To do this, we'll just plug in these values into this formula right here, the nth term formula. So we have an is equal to a1, which is 11, plus n, just stays as n minus 1 times the common difference of negative 7. Okay, we'll just simplify the right side as much as possible, and that will be our explicit formula. We have a parenthesis here, which means we are to distribute, so we'll distribute this negative 7 to the 2 terms in the parentheses. So that gives us an equals 11. Negative 7 times positive n is minus 7n. And then negative 1 times negative 7 is positive 7. Remember, negative times negative is positive, okay? Now to simplify, we have a constant here and a constant here, so we can combine those two, and we get an equals 11 plus 7 is 18 minus 7n. And that, ladies and gentlemen, is the explicit formula for the given arithmetic sequence. Okay, so let's just put a side note here. This is the explicit formula. Now, is this formula correct? What we have to do next is the verification. Let's verify if this formula is correct. Now, for the verification, we're going to generate the 5th, 6th, and 7th term using this formula and see if they match with what we got here. Okay, so let's go ahead and do it. Let's start with the 5th term. So let's rewrite the formula here. An equals 18 minus 7n. That's what we're trying to verify. For A5, we have 18 minus 7 times n is 5 in this case. Okay, for A5. Let's simplify this. We are going to have 18 minus 7 times 5 is 35. And then when you subtract these two, you get negative 17. For A6, we have 18 minus 7 times n is now taking the value of 6, so put 6 here. So it's 18 minus 42. You can subtract this mentally or you can use your calculator. You get negative 24. A7 is 18 minus 7 times. N now has a value of 7 for the 7th term. So we have 18 minus 49. When you carry out the computation of the difference of these two numbers, you end up with negative 31. Alrighty, so is this explicit formula correct? Let's compare our answers. Negative 17, check. Negative 24, check. Negative 31. That tells us that our explicit formula is correct. Okay, so next thing we have to find is the recursive formula. Okay, so part E, we have to find the recursive formula. So to find the recursive formula for this arithmetic sequence that we have, let's write down what the formula, the general form for a recursive formula for an arithmetic sequence is. Okay, so it's comprised of two parts. You have the initial term. A1 is going to be the first term, and you also have another component known as the recursive formula, which is an minus 1 plus d. This is just for arithmetic sequences. Okay, so if we apply that idea to this problem that we are dealing with right now, we know that the first term a1 is 11, and our common difference is negative 7. So let's plug it in here. A1 is 11, and then a sub n is going to be the term before it, a sub n minus 1 plus the common difference, which is negative 7. And this becomes a sub n minus 1 plus times minus is minus 7. Okay, so our recursive formula is going to be starting term of 11 and the recursive formula of a sub n minus 1 minus 7. Okay, so this is the answer for part E. Let's put the side note here. You know we have explicit right here. That's the explicit. It's just one formula. And then we have the recursive. Recursive has two parts. Okay, the starting term and the recursive formula. Alright, so that's that. Now the last part, part F, we are to figure out what the 52nd term is. Okay, 52nd term. Okay, so there are two options here. We can use the formula for the nth term of an arithmetic sequence. Where is it? We could use this formula right here, or we can use the explicit formula, which is the nth term formula adapted to this particular scenario. You can pick whichever you want. The explicit formula looks easier because we just have one input to plug in. This one you have to put in a1 and n and d, but it doesn't matter. But I want to go with the one that's easier. Besides, we have tested this explicit formula and it works, so we're confident that it's going to be reliable in determining our 52nd term for part F. Okay, so let's write down the formula for determine the nth term. In this particular case, the nth term formula for this sequence is 18 minus 7n. Okay? So let's apply it. For the 52nd term, a sub 52, what do? We just simply plug in 52 in the place of n, like that. Okay, now let's simplify. You have 18. If you work this out in your calculator, 7 times 52 is 364. And then when you subtract these two from each other, you end up with negative 346 as the 52nd term of this arithmetic sequence. Okay, so that's that. Thank you so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of sequences and series, do give us a thumbs up. Your positive feedback is very valuable and supportive to us. If you have any questions about the contents of this presentation or any Algebra 2 concept in general, just place your questions in the comment section below, and we or some of our other viewers will be glad to respond. Don't forget to subscribe to our channel for updates to videos we always upload to our channel on a consistent basis. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.